Okay, let me be straight with you from the very first second, because I hated when channels waste your time. NVIDIA didn't technically build a notebook. The thing I'm about to spend the next 10 minutes geeking over and over is a little box that sits on your desktop. But here's the wild part, and the reason that the title isn't totally lying to you. This little box does something your MacBook physically cannot do, no matter how much money you throw at Apple. And once you see what it actually pulls off, you'll understand why people keep calling it the most powerful personal machine on the planet. So stick with me, because this one is genuinely exciting. This little thing is called the NVIDIA DGX Spark. You might have heard it whispered about under a different name first, because back at CES in January of 2025, NVIDIA teased it as the Project Digits. This pitch they made that day was honestly kind of bold. Jensen Huang got up on the stage and basically said he wanted to put a Grace Blackwell AI supercomputer on every developer's desk and every researcher's fingertips. And I remember rolling my eyes a little, because that's the kind of thing every tech company says. Everybody promises the future and almost nobody ships it. Well, NVIDIA actually shipped it. It actually went on sale on October 15th of 2025, sold through NVIDIA directly and through pretty much every big name you know. Acer, Asus, Dell, Gigabyte, HP, Lenovo, MSI, all of them. And the form factor is the first thing that messes with your head. It's tiny. We're talking about something that fits in your palm, roughly the size of a small stack of books, finished in this gold textured shell that honestly looks more like a piece of art than a computer. NVIDIA keeps calling it the world's smallest AI supercomputer, and for once, the marketing line isn't total nonsense. Here's where I started leaning forward in my chair though. At the heart of this thing is NVIDIA's GB10 Grace Blackwell superchip. And the word superchip sounds like fluff, but it's actually describing something specific. They glued a CPU and a GPU together into one coherent unit. And they did it the way they do it in their massive data center hardware, just shrunk way down. On the processor side, you get a 20-core ARM CPU split into 10 high-performance Cortex-X925 cores and 10 efficiently focused Cortex-A725 cores. On the graphics side, you get a full Blackwell GPU, the same architecture family powering the AI boom and server farms around the world, complete with 5th generation Tensor cores. NVIDIA rates the whole package at up to 1 petaflop of AI performance. 1 petaflop. That's a quadrillion operations a second sitting on your desk, sipping power from a normal wall outlet. You also get 4 terabytes of fast NVMe storage, so you're not constantly juggling files, and it ships with NVIDIA's own DGX operating system, which is a Linux built that comes preloaded with their entire AI software stack. That last bit matters way more than it sounds, and I'll come back to it later. Alright, this is the headline feature, and it's the thing I actually want you to remember if you forget the rest of the video. The DGX Spark has 128 gigabytes of unified memory. Let me explain why that number is a big deal, because on paper it just looks like a lot of RAM. Normal graphics cards have a hard ceiling on memory. A high-end RTX 4090, the card gamers drool over, has 24 gigabytes. Even NVIDIA's Monster H100 data center chip tops at around 80. Once your AI model is bigger than that ceiling, you're just stuck. Game over. You can't load it. The Spark throws that ceiling out of the window. Thanks to an interconnect NVIDIA calls NVLink C2C, the CPU and GPU share that full 128 gigabytes at the same time, with way more bandwidth than you'd get shoving data through a regular PCIe slot. In plain English, that means you can load and run genuinely huge AI models, the kind with up to 200 billion parameters locally on your desk completely offline. And if 200 billion somehow isn't enough for you, you can physically link two Sparks together using built-in Connectix network and run models up to 405 billion parameters across the pair. That is simply bonkers for a machine this size and at this price range. This is the part where your MacBook just cannot follow. Even trying to load a 120 billion parameter model on a MacBook will make it fall over. The Spark does it before breakfast. Now, I promised you I wouldn't blow smoke, so here's the asterisk, and it's an important one. The Spark is not the fastest machine on Earth at every task, and anyone telling you otherwise hasn't read the benchmarks. The catch is something called memory bandwidth, basically how fast the machine can shovel data around internally. The Spark runs at about 273 gigabytes per second. That sounds fast until you compare it to an Apple Mac Studio, which pushes well over 500 gigabytes per second. And for one specific job, generating text token by token after the model gets going, that bandwidth is king. So in some tests on big models, a maxed out Mac Studio actually spits out words faster than Spark does. There's a benchmark floating around where running a 120 billion parameter model, the Mac was hitting around 60 tokens a second, while the Spark sat lower. I'm not going to pretend that didn't happen. It did, and Apple really did show better performance. But, and this is a real but, where the Spark absolutely smokes the competition is the other half of the work, reading and processing your prompt in the first place. In one head-to-head, the Spark chewed through prompts at nearly 3 times the speed of the rival machine. So if your work involves feeding the AI huge documents to digest, the Spark is in a completely different league. On smaller, optimized models, it's a rocket too, clocking over 900 tokens a second on a Llama 3.18 billion model. And NVIDIA isn't sitting still. At CES in early 2026, they pushed a software update that delivered up to 2.5 times the performance on certain workloads compared to launch day, just from smarter software. That's the kind of thing that keeps a machine getting better after you've already bought it. All of this brings us to the key question, and that is, does it actually destroy MacBooks? And here's my honest answer, and it's a yes and a no. So hear me out. If you want a laptop to write emails, edit a vacation video, browse the web, and look gorgeous in a coffee shop, a MacBook destroys the Spark, because the Spark literally isn't a laptop and doesn't even have a screen. That comparison doesn't really make sense, and I'd be lying if I dressed it up. But if what you're actually caring about is running serious AI on your own hardware in your own home without sending a single byte to the cloud, then it's not even close, and the MacBook isn't in the conversation. No MacBook on sale today can hold a 200 billion parameter model in memory and run it. The Spark does that as its day-to-day job, and the secret weapon, the thing I think people underrate, is the software, because the Spark runs NVIDIA's full stack out of the box. The model you build and tweak on this little gold box runs on the exact same architecture as the giant data center system NVIDIA sells to the biggest AI companies on Earth. You prototype at your desk and then you scale it up to the cloud with basically zero friction. That continuity is the real magic, and Apple simply has nothing that does it. Now, let's talk money, because it's not pocket change despite being affordable at a larger scale. The Spark launched at $4,000, $3,999 to be precise. Then, in February of 2026, NVIDIA bumped the official price up to $4,699, and they were pretty upfront about why. There's a worldwide shortage of memory chips right now. The exact LPDDR5X memory memory this thing is packed with, and prices went up across the whole industry, so that's the going rate, with partner versions floating around at various prices, some a bit cheaper, some a lot more expensive. And look, I'll say it plainly, this is not a machine for casual buyers. If you want to mess with a chatbot now and then, save your money, do not need something like this. This is built for AI developers, researchers, students getting serious about their field, robotic folks, and small teams who want a real lab on their desk instead of a monthly cloud bill that never stops climbing. I think that the DGX Spark is one of the coolest pieces of hardware I've looked at in a long time, and I mean that. Is the clickbait true? Will it literally destroy every MacBook forever? No. Not in the way that phrase suggests, but does it do something genuinely new? Something Apple can't touch in a box smaller than your lunchbox and for the price of a nice laptop? It absolutely does. What gets me is the symbolism of it. 10 years ago, the kind of AI horsepower in this little gold brick lived only in rooms full of screaming server fans that cost a fortune. Now it sits quietly on a desk and runs off of wall plug. That's the actual story here, and it's a beautiful one. The future of personal computing isn't a thinner laptop, it's your own private supercomputer, and NVIDIA just put the first real one in people's hands.